My name is Kaleya Kramer, and I am the leader of Acqualibria. Our goal is to work with the Ivo Di Carneri Foundation to design sustainable solutions to provide food and water security to local cooperatives on the island of Pemba. Our solutions included a water filter designed to remove local parasitic diseases from the water, such as schistosomiasis, as well as an aquaponics system to quickly grow large amounts of nutritious food, such as fish and plants.
Hi, my name is Chris Vance and I serve as liaison between Ivo Di Carneri Foundation and ethics. The Ivo Di Carneri Foundation is an NGO based in Milan, Italy, that promotes control strategies for parasitic diseases, specifically schistosomiasis, on Pemba Island in Africa. The foundation collaborates with the government of Zanzibar and local cooperatives to accomplish specific goals: strengthen public health systems, train local healthcare workers, encourage young researchers to conduct operational research in fields of parasitic and infectious diseases, and developing economic partnerships with local cooperatives.
Hi, my name is Nan Win, and I've been looking into the most optimal design for our aquaponics system. The key to a successful design is the compatibility of the components. We focus on the interaction of fish and plants, ease of use, and cost. The most feasible design for our aquaponics system is a media-based system, which requires media-filled beds along with water pumping through them where the plants will grow up. Since the end user of our design will be the cooperative off the coast of Tanzania, we will need a simple system that is easy to maintain.
My name is James Wood and I'm here to talk to you about another important component to our aquaponics system, crop selection. With our aquaponics system, we look to meet both nutritional and economic needs on the island of Pemba. By growing foods rich in vitamin A, iron, and beta-carotenes, we meet both the nutritional deficiencies of the local population as well as eliminate the economic strain of having to import these fruits from other countries. With our system, we look to test both romaine lettuce and kale.
We researched several different fish within the constraints of the specifications of our system. The breed of fish that was most compatible with our system, the climate of Pemba, and the dietary needs of the locals was tilapia. Tilapia thrive in warm water, which is perfect for the island of Pemba, and they are not dependent on pristine sources of water in the event that we need to use lake water in our system. Also, they serve as a nutritious food source. The breeds of tilapia that we decided to go with were blue tilapia and Nile tilapia.
Pumps are required in aquaponics to be able to carry water throughout the system. They vary in their output, mainly based on the vertical lift that they are pumping water over. And they need to be able to turn over all the water in the system every hour. Aeration is required in aquaponics to provide a fresh source of oxygen for the fish. Our two choices for pumps are either electrical driven or with an airlift pump, depending on whether the location of the site will have electricity available. And our choices for aeration vary depending on the size of our system, but we will most likely have a filter which rotates the tank water from the bottom of the tank up, which is important because that part of the system is not gaining oxygen from the air.
Currently, we are working on our biosand filter, which has several parts. I'm working on the bio layer of the filter, which is also called the Schmutzdeck. This is the first filtering layer of the system that is composed of several bacteria, protozoa, and other viruses. The bio layer will filter out the schistosomiasis disease that is in the water, and we hope to culture our bio layer over winter break, since it can take up to 30 days to form. There are also other components to the filter, such as the sand/gravel and the design features.
Industrial sand is a high purity silica sand with closely controlled sizing, which is the best option for the sand filter due to grain shape and size. A 0.6 to 1.2 meter layer of sand will be needed to place on top of a 0.3 to 0.5 meter layer of gravel.
The concept of the design model for the filtration system will utilize gravity to help filter out parasitic diseases out of the water. The filtration system works by first having an open source of water and pumping it vertically above that of the biosand. From there, gravity can be utilized and push the water through the biosand and collect it at the bottom. Our current design model uses 3 water tanks, a clear pipe, and an electric pump. Tank 1 will represent the original source of open water. The pump will move into tank 2, which holds the water above the biosand. The clear pipe contains the biosand, and gravity will push the water through the sand and collect it at tank number 3.